Hi, this is Victor and welcome back to my math tutoring channel. In this video, we'll solve that integral. And if I look at my integral, I can write it in a better way, which is integral of square root of x squared plus 6x. Instead of putting to the power 1/2, I can substitute it by square root. And looking at that integral, if I take my u equal x squared plus 6x, my du will be 2x plus 6. But I don't have another x beside my dx, and my du have an x, so it's not a good idea. But looking at it, x squared plus 6x, it's the beginning of a perfect square. So I can write it like this: x squared plus 6x plus 9 minus 9 dx, because I know that x plus 3 square is equal x squared plus 6x plus 9. So that's why I added 9 here and I subtracted 9 from it. So this part become x plus 3 square. So my integral become x plus 3 square minus 9. And there is a square root here, dx. So here if I say let u equal x plus 3, my du is equal dx. So my integral become u square minus 9 du. And I have a video, it's called Step-by-Step Integral by Trigonometric Substitution. I will put the link of that video in the description of this one, so if you want to understand it better. But I will explain it briefly in this video. In the other video, I explained if I have a square minus x square, where x is my variable. In my case, it is u, my variable. So if I have a square minus x square, I would take x equal a sine of theta. And if I have a square plus x square, I will take my x is equal a tan of theta. And if I have x square minus a square, which is the case here, the variable square minus a constant square, I will take my x is equal a sec of theta. So in my example here, the a is a constant. I have a square, it's 9, so the a is 3. So I will take let u equal 3 sec of theta. So my du would equal 3 sec of theta tan of theta d theta. Okay? And every time that I want to use integral by trigonometric substitution, I have to draw my famous triangle, and that's my theta. And I don't know where to put the 3 or where to put the u. Is it the hypotenuse? Is it the adjacent or the opposite line? But to know, I know that u equal 3 sec of theta. So sec of theta is equal u divided by 3. And I know the sec is 1 over cos of theta equal u divided by 3. But usually cos of theta equal adjacent divided by hypotenuse. So 1 over cos will become hypotenuse divided by adjacent. So my sec of theta is equal the hypotenuse divided by the adjacent line. So that's my theta. The hypotenuse is here, and the adjacent is here, because I have u divided by 3. So here sec of theta equal u divided by 3. And here, if you use Pythagoras theorem, you will have u square minus 9. I was doing integral of u square minus 9 du. So the integral was u square minus 9 du. So now I will replace u by its value, which is here. So it become integral of square root of 9, because 3 square is 9, sec square of theta minus 9. All what I did is I put this to the power of 2. And my du, we just did it here, my du is 3 sec of theta tan of theta d theta. So times 3 sec of theta tan of theta d theta. And my square root ends here. Inside my square root, I can factor out 9. So my integral become, let's keep it like this, sec of theta, sec square of theta minus 1 times 3 sec of theta tan of theta d theta. So the 9 can go outside my square root as 3, and I have 3 here, so 3 times 3 is 9. So I would have 9 square root of sec of square of theta minus 1. So the 9 went out as 3, but I multiplied it by this 3, that's why I put 9. And I have here sec theta tan theta d theta. So I know sec square of theta minus 1 is equal to tan square of theta, and the 9 can go outside my integral here. So it becomes 9 square root of tan square of theta sec of theta tan of theta d theta, and square root of tan square of tan square of theta is equal tan of theta. So 9 integral. So this is tan of theta times this tan of theta, it becomes tan square of theta sec theta d theta. And here the tan, I can write the tan square as sec square of theta minus 1. So 9 integral of sec square of theta minus 1 times sec of theta d theta. And let's multiply sec of theta by everything in the parentheses. So it becomes 9 sec to the power of 3 theta minus sec of theta d theta. Here I have to put the parentheses. And now I can divide it into two integral. The two integral become 9 integral of sec to the power of 3 theta d theta minus 9 integral of sec of theta d theta. But this is very easy, sec of theta d theta. I know the integral of sec of theta is equal ln of tan of theta plus sec of theta. So that part here become minus 9 ln of sec of theta plus tan of theta. Actually it's absolute value because ln is always positive. I will put the plus c at the end. So now let's work on that side, and let me highlight this so I can go back to it after, because I have to add it to the end of my integral. This is plus c. And you know what? I'm gonna choose another color to, I don't want to forget it. This I have to add it at the end of my integral. And now let's work with this part of the integral. So let's take back the blue color. So let's work with 9 sec to the power of 3 theta d theta equal 9 sec square of theta times sec of theta d theta. Here I can say let u equal sec of theta my du is equal sec of theta tan of theta d theta. And if I take my v is equal, my dv actually is equal sec square of theta, my v is equal to the integral of sec square of theta d theta. And it's a formula. I know the integral of sec square of x is tan of x. So my v will become tan of theta. So this is my u and this is my v. And I will do integration by part. Integration by part formula, u dv is equal uv minus integral of v du. And now let's copy 9 integral of sec to the power of 3 of theta d theta equal the u is equal sec theta, and my v is tan of theta, minus integral of v, which is tan of theta, du, which is sec theta tan theta. Sec theta tan theta d theta. Let's copy it. So my 9 integral of sec to the power of 3 theta d theta equal sec theta tan theta minus, here tan theta times tan theta is equal tan square of theta sec theta d theta. But I know that tan square of theta is equal sec theta minus 1. So let's highlight this. I don't want to copy it all the time. This I have to add it again, and I will be working on that part. So if I take integral of tan to the power of 2 of theta sec theta d theta, I know the tan is equal, tan square is equal sec square minus 1. So it's equal sec square theta minus 1 multiplied by sec theta d theta. And here I want to develop this. So it is equal of sec to the power of 3 theta minus sec theta d theta, and that's very easy it becomes. So this is equal sec to the power of 3 theta minus sec theta d theta, and here there is d theta, and I know the integral of sec of theta. Integral of sec of theta actually is ln of sec theta tan theta. So this is minus ln sec of theta plus tan of theta plus c, and this sec 3 of theta, now I will rewrite what I did not write here. So I will have 9 integral of sec to the power of 3 theta d theta is equal to sec theta tan theta minus integral here of sec to the power of 3 theta d theta minus, here I have the minus 1 minute. So I have that minus for all that, so that minus here times that minus there is plus ln of sec theta plus tan theta, and I will add the plus c at the end. So you see this sec theta d theta, if it come to the left hand side the equality, the minus become plus. So 9 integral of sec theta d theta plus integral of sec to the power of 3 theta d theta equal sec theta tan theta, which is this, plus ln of sec theta plus tan theta. So now let's keep the 9. This sec theta plus sec theta is 2 times sec theta. So 9 times 2 times integral of sec to the power 3 of theta equal sec theta tan theta plus ln of sec theta plus tan theta plus c. I have the space here. So now I need the sec theta, so I have to divide by the 2 here. And I will keep the 9. So 9 sec to the power of 3 of theta is equal 1/2 sec theta tan theta plus 1/2 ln of sec theta plus tan theta plus c, and you will see why I kept 9 here, because I have to add this and I have 9 here. So 9 ln of sec theta plus tan theta. So 9 integral of sec to the power 3 of theta is equal minus 9 ln of sec theta plus tan theta minus 9 ln of sec theta plus tan theta plus 1/2 here, 1/2 sec theta tan theta. I added this, and now I'm adding this, plus 1/2 ln of sec theta plus tan theta plus c. So I can divide, I need sec to the power of 3 of theta. I can divide by 9 here, and everything here divided by 9, divided by 9, divided by 9. So my sec to the power 3 theta is equal minus ln sec theta plus tan theta, and I have 1/2 divided by 9, it becomes 9/2 plus 9/2 sec theta tan theta plus 9/2 ln of sec theta plus tan theta plus c. And now we did not, and here all what I have to do is replace theta by, what did we take theta as? Let u equal, where is theta? Here. So here we took, let's write it down. Let u equal 3 sec theta, then sec theta equal u divided by 3, and then theta is equal arc sec, or sec minus 1, arc sec u divided by 3. So all what we have to do is we replace theta by arc sec u divided by 3, and that would be the final answer. So we come here, minus ln of sec arc sec theta divided by 3 plus tan arc sec theta arc sec theta. I will let you do that, and that would be the final answer. You replace every theta by arc sec theta divided by 3. Every theta here, 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 and that would be your final answer. So if you like my video, please subscribe to my channel. That would help me a lot, and if you like it, I would appreciate if you put a like or if you share it with your friends. Thank you very much.